Why time actually slows down when you move faster. Have you ever wondered what would happen if you could travel close to the speed of light? Would you see the stars blur past like streaks of fire? Maybe. But the real mind-bending part isn't what you'd see. It's what happens to time itself. Because according to Einstein's theory of special relativity, the faster you move, the slower time passes for you. Yeah, time actually slows down. Section 1. The everyday view of time. In everyday life, time feels constant. 1 second on your watch feels the same as 1 second on someone else's. You get older, your coffee gets cold, and the world spins at its usual pace. But that's because we move at relatively slow speeds compared to the speed of light, which is about 186,000 miles per second. At those cosmic speeds, time starts to get flexible. Einstein showed us that time isn't a fixed background that ticks away the same for everyone. It's part of something bigger, a four-dimensional fabric called space-time, and when you move through space faster, your motion through time slows down to keep the balance. Section 2. The light clock thought experiment. To see how it works, imagine a light clock. It's a simple device. A beam of light bounces up and down between two mirrors. Each bounce, up and down, counts as one tick of the clock. Now, if that clock is sitting still, the light travels straight up and down. But what if you start moving the whole clock sideways at high speed? From the outside, you'd see the light traveling in a diagonal zigzag, covering more distance with each bounce. Here's the catch. Light always moves at the same speed, no matter how fast you're going. So, if the light in the moving clock has to travel a longer, diagonal path at the same speed, each tick must take longer. That means the moving clock runs slower, and if the clock runs slower, so does time itself for whoever's moving with it. This isn't a trick of perception. It's an actual, measurable effect called time dilation. Section 3. Real world proof. The twin paradox and atomic clocks. This isn't just theory. Scientists have tested it. And time dilation is real. Take the famous twin paradox. Imagine one twin stays on Earth while the other blasts off in a spaceship traveling close to light speed. When the traveling twin returns, they'll actually be younger than the twin who stayed home. Both experience time normally in their own frame, but one's clock literally ticks slower because of the extreme speed. We've even seen this effect on a smaller scale. In the 1970s, scientists flew atomic clocks on airplanes and compared them to identical ones on the ground. After the flight, the clocks in the air had lost time. They ticked just a tiny bit slower, exactly as Einstein predicted. Even GPS satellites have to correct for this effect. They move fast enough and are far enough from Earth's gravity that their onboard clocks run slightly faster or slower than ours on the ground. Without Einstein's math built into the GPS system, your phone's location would drift off by miles each day. Section 4. The cosmic perspective. So what does all this mean? It means there's no universal now. Time is relative to how fast you're moving and where you are. If you could somehow travel near the speed of light, you could cross the galaxy and come back to find that decades passed on Earth, while you only aged a few years. It's not science fiction. It's the universe's way of keeping the rules of physics consistent for everyone. So, next time you're late for work, don't blame traffic. Blame Einstein. Because technically, the faster you go, the slower time moves for you. The problem is, you'll need a spaceship, not a speed limit violation, to notice it.